Right, hello everyone. So today we're going to have a look at trig functions. So I'm going to show you the basic structure and then I have some stuff prepared for you. So the basic structure is a plus b times the sine of cx, where a, b, and c are elements of the real numbers, and where x is either going to be an angle in degrees or an angle in radians. Okay, so I'm going to show you what I mean by this by having a look at a couple of different ones. So this would be one like this, sine of x. Okay, so in this case, the a value, there's nothing in front of it, so the a value would be 0. The b value is whatever number is in front of this sine, so the b value would be 1, and the c value would also be 1. Okay, so that would be the structure of something like this. Then if I make this sine of 2x, the a value is still 0, the b value is still 1, but now the c value is 2. Let's say I do the 2 cos 3x. Well, the a value is still 0, the b value now is 2, and the c value now is 3. And let's try one more. 4 minus 3 cos 4x. So in this case, the a value is 4, the b value is minus 3, and the c value is 4. Okay? Now, when we come back and look at this in a while, there's going to be some more little finesse, but that's basically how to figure out the a, b, and c. As it gets more complicated, you will have definite numbers for all three, a, b, and c. But in its simplest form, a will always be 0, b will always be 1, c will always be 1, because there's no other numbers visible. When there's no other numbers visible, that's the assumption you make. Okay, so I'm going to show you what happens when we draw these. So, this is just in case, because I really want everyone to kind of be on board with this. This one is the sine of x function. Just the sine of x function, nothing else. There's no numbers, there's no a, b is 1, c is 1. This is the simplest one you can get. So as you can see, and we'll just look at the right-hand side of the x-axis here, top and bottom. We won't bother looking at the left, but it repeats on the left. So the sine of 0 degrees, or the sine of 0 radians, is 0. The sine of 90 degrees, or the sine of pi over 2 radians, is 1. Then it repeats down to at 180 degrees, or at pi radians, it goes down to 0, and then repeats. So I'm going to show you the structure of this. This distance here will always be the amplitude. Okay? The period, how often it repeats, will always be from here. You can pick any 2 points that are corresponding. So if I look at here and I look at here, that's where this starts again. So that's its period. So its period is from there to there. That's its period. Its range is from here to here, how high or low it actually reaches. Okay, so amplitude, period, and range. That's all you really need to know, and you can get all this information from the function without having to draw it, or you can figure it out from the... So I'm going to show you, for the sine of x, the amplitude is 1. Okay, the range is 1 to minus 1. The period is 2 pi. Okay, and if you notice carefully, and I'll show you this with a ruler, the midline, the symmetrical midline, where half of it is above and half of it is below, is along the x-axis. And we'll come to why that's important later on. So I'm going to get you to have a look now at a second one. So the second one you're going to have a look looks very similar. This one is the cos x function. Okay? So you notice the only difference is it's being shifted this way. So instead of starting at 0, it starts at 1, then dips down, and then repeats. So let's work out its range. Its range is still the same. -1 to +1. its period, well, let's have a look. From there right over to there, 2 pi. There's its period. And its amplitude is still 1. So nothing has changed apart from its position. So that's sine x and cos x. You notice there's no numbers apart from the ones that were invisible. There's a 0 there, there's a 1 there, there's a 1 there. So on its most basic, that's what it looks like. Now, I'm going to show you what happens when we add a bit of fun to this. Let's have a look what happens to the tan. So there's the tan of x. So if you notice, it starts and it makes its way up, but it'll never reach pi over 2. So this one is interesting because if we look at all the previous ones, this is important to show. In the previous ones, every value along the x-axis has a corresponding y value. Every value. So I can pick a value in here, a degree or a radian in here, and it'll give me an answer out. I could pick a degree or radian in here, and it'll give me an answer out on the y-axis. However, it's bounded. It doesn't have an infinite amount of answers it's going to give me. Because here, the most it'll give me as far as 1, it won't give me 1.5, and down here, -1. So the domain, for want of a better word, is the entire real numbers. All the possible degrees and radians you could ever have. The range, however, is limited to plus or minus 1. And anything in between there. Now let's have a look at the tan function. The tan function, it skips. So at 90, it doesn't have an answer. So every other 90, from 0 to 89.99999, you will get an answer. When I pop any of those numbers in, I'll get a corresponding y value out. But not at 90. And not here either, 270. So every 180 degrees, from 90, 270, keep adding on, it'll suddenly no. So it's the entire real numbers minus those numbers, which is a weird one. But for every other possible number, you can get an infinite amount going top to bottom of y. So it's not bounded like the other one with the plus or minus 1. It keeps going on. Its range goes on. So let's have a look at what happens when we move these a little bit. So let's introduce some numbers now. So the first number I'm going to look at is what happens when I put a number in front of the x value. So remember, instead of sine x now, I'm going to go sine 2x. Okay, so this orange one represents the sine of 2x. So what you'll see here is the pattern, because the number is the number, this C, A, B, C, this C number, because it's greater than 1, it shortens the period. So the original period for the sine of x is 2 pi. Now our period is just pi. So a number greater than 1 in front of the x, whether it's sine or cos, will shorten the period. Now, this blue one represents what happens when I put a number less than 1. This is the sine of x over 2, or the sine of a half x. Although no one ever writes it like that. They'd always write it like that. So when the c value is less than 1, it stretches out the period. So these are the same function. Look, they're still bounded by +1, -1. That still range is still there, but the period of this one now goes zoom, 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 and it's off into the distance. Okay, so it's a huge period. I think it's 4 pi. So that's what happens when you introduce a number in front of the x. Now, let's have a look and see what happens when we add in another number. Let's see what happens when we put in a number in front So have a look at this one. So in this case, we have a number in front. So I'll have to write down what this function is. One of these functions is 2 cos of x, and one of these functions is half cos of x. So let's see which one is which. Okay, so 2 cos of x stretches the function. The period remains the same because there's no number apart from 1 in front of that. It's not greater than 1, not less than 1. So in front of the x there's no number, so the period of cos stays the same as 2 pi. However, it has stretched it on the y-axis. So the number in front, if it's greater than 1, will stretch it. And obviously if the number in front is less than 1, like this one, the green one, it contracts it. Okay? So that's your second rule. This is your b value. Your b value controls the amplitude, the stretch on the y-axis. Okay? Your c value controls the period, the stretch on the x-axis. Now, you're asking yourself, well, what does a do? Okay? So, this is what a does. What you're looking at here is 2 for the price of 1. Okay? So, there's our midline, or line right through the middle. Okay, so I want you to pay particular attention to the blue line. The blue line represents 2 plus the cos of x. The red line, or orange line, represents 2 minus the cos of x. So let me explain what this a value does, and then let me explain what the plus and minus does. The a value moves the midline. Every other one we've done, okay, if I look back to this one, every other one we've done has been along the x-axis as our midline. The a value moves that up or down. So if it's a 2, the midline is at 2. If that's a -2, it's down here at -2. That's all it does. However, if there's a plus or a minus in front of the actual function, then it flips the function upside down. So the blue is our traditional cos function. The orange or red is the minus version of it. It's just inverted upside down. And that's all it is.